is Vincent Lesierse. I'm a solution architect working for AWS. I help customers being successful in AWS for a year and a half. In this talk, I would like to show you how you can build applications using Go with AWS CDK and how to deploy them to your AWS account. So let's get started. Okay, let's start at the beginning. It starts with manual deployments where we use like wikis and playbooks, which were sometimes outdated, or you actually ask someone to click your infrastructure through the AWS console. And if something needs to be changed, it would be hard to see who to approach for that and what was actually done into your AWS account. The next track was actually a bit better. It was scripting things in Bash. And it worked very well until the complexity was too big. Because Bash was not really designed to build complex deployment frameworks, and it was usually hard to maintain. So it started working quite well until it grew and became more bigger. Usually the advice was like, hey, it worked the last time, so don't touch it. An important next step what has been taken is the use of CloudFormation or Terraform. That was like those infrastructure provisioning engines would actually hide the complexity of things like state management, but also include features like rollbacks or error management or drift detection. And actually, it allowed developers to describe their infrastructure in a declarative way and hand it over to the engine, which start deploying the resources on the account. Actually, the ease of use increased the adoption of infrastructure and code among companies and enterprises and in the development communities. This actually led to a growth in size of the templates, which eventually made it harder to maintain because it's hard to maintain growing sizes of declarative files like JSON and YAML, and you can imagine that also got into some problems. So the next idea was to use generators, which actually allows you to write code, transform that, and generates JSON and YAML documents from classes and methods you already know in programming languages. And on top of that, there came new tools such as AWS CDK and Pulumi, which actually provide you with a set of tools and framework to create custom abstractions and cloud infrastructure. So let's take a look at AWS CDK. The AWS Cloud Development Kit is an open source development framework to model and provision your cloud infrastructure resources using the programming languages you already know and love. So you can do this with different programming languages like Python, TypeScript, Java, C#, JavaScript, and very recently you can also use Go, which is currently in preview. With CDK, you will be much faster than with the previous tools because you can work with familiar languages and concepts like classes and methods without you have to switch in context. You also have all the tools and support from programming languages such as autocomplete, inline documentation, testing, linting, and use of a debugger. By actually writing your code within the IDE you already know and love. The most important part is that you're able to build abstractions and components of infrastructure and applications. And we provide many sane default values, so there's no need for you to read a lot of documentation to get started quickly, and also in a safe way. And of course, many of these default values can be adjusted to your needs. So let's take a look at the components that AWS CDK consists of. So first we have the core framework. We have the AWS construct library, and we have the command line interface. So with the core framework, you can create and structure apps that contain one or multiple stacks. A stack is a logical unit of infrastructure which contain multiple resources and is mapped one-on-one to a CloudFormation stack. It's a good practice to divide the resources into stacks that have different life cycles, and you will create one stack of network infrastructure such as VPC, another stack which have like a container cluster using EKS or the Elastic Container Service. Or you have another stack, which actually is the application that runs on top of the cluster. The AWS construct library is a set of components, which is crafted by AWS to create resources for specific services. This helps you to decouple libraries and use only the dependencies that you need in your project. It also built with best practices and security considerations. To provide good development experience, ease of use, and a fast iteration lifecycles. The CDK CLI help you to interact with the core framework and to initialize project structures, inspect differences between deployments, and also deploy easily towards your AWS accounts. So let's take a look at an example. Here's where we create a new VPC, an ECS cluster, and an application with the application load balancer by just providing the name of the Docker image from Docker Hub and a number of maximal availability zones of a VPC. And that's it, nothing more than this. CDK will generate more than 800 rows of CloudFormation template with separate VPC, subnet, internet gateway, routing tables, application load balancer, the Fargate cluster, service and task definitions. So in total, like 37 resources with just these amount of line of codes. Now let's see how we can use the development flow of CDK and how we can actually ship this code to our AWS accounts. So we start a project by executing the CDK init. And this will actually generate a project structure for a specific programming language. And we can start creating our apps and stacks and the constructs and resources that are needed. Once we have created the project, we can actually build it already by using Go build. Or if you're using TypeScript, you could use npm run build. But this is the next step. You're now able to build your application with the code that has been provisioned. Then we need to synthesize our code to CloudFormation templates. And you can do this by running CDK synth. And this will actually generate the CloudFormation templates and the assets needed, and that will be bundled in something called a Cloud Assembly. Before we deploy, we can actually inspect what to change if we deploy the Cloud Assembly. And which resources will be deleted, will be updated, or will be created. We can do this by using CDK diff. And finally, with CDK deploy, we can push the changes to CloudFormation, and from there the service will create all the cloud resources necessary into your AWS account. So let's take a look at the CDK constructs. So CDK includes the AWS construct library, which contains constructs representing AWS resources. And this library includes constructs that represent all resources available on AWS. For example, the S3 bucket class represents an Amazon S3 bucket, and the DynamoDB table class represents a DynamoDB table. With this library is the starting point for you to create the resources, and is one of the big advantages is to have composition of the services that represents like complex infrastructure, like networking setup, or creating clusters or databases. And let's take a look at the various levels of constructs and how you can actually use them. So constructs are organized in 3 different levels. A level 1 are constructs that automatically generated from CloudFormation resource specification. So this is a one-to-one mapping between classes and AWS resources. Level 2 are higher level service constructs and actually represents resources such as S3 buckets or a VPC, and including all the resources, so it can be a composition of multiple that still be tied to one service. So these constructs are simpler and require very little input to generate complex CloudFormation templates. And they can have many defaults and opinions already baked into them. Level 3 are opinionated abstractions that are created by AWS, for instance, ECS servers with an application load balancer and a VPC. But you can also see level 3 constructs in third-party libraries provided by the community, or your own set of libraries that you want to distribute into your organization. And this is the level where you're going to create your own abstractions that can be reused. So let's take a closer look to a level 1 construct. So with a low level 1 construct, you actually have direct access to the generated CloudFormation elements. And this provides control, but also requires the knowledge about the properties of the resource specification. All fields are optional in here, and CDK tries to generate properties where it can, such as names or well-defined defaults. So as you can see over here, it says a new CFN bucket. So usually level 1 constructs are prefixed with CFN, which stands for CloudFormation. And in this case, we can give it the name my bucket, and we can also specify the bucket name over here. A level 2 construct can generate more complex structures. So they can contain multiple resources, but they are still in scope of the specific service. So with a single line of code, we can actually create a VPC that spans 2 availability zones, which include 4 subnets and have more than 65,000 IPs split at equality. We have an internet gateway, route tables, and everything, and is actually all what you need for a fully configured VPC according to the AWS security best practices. Anyone who actually built a VPC from scratch in CloudFormation, I think you can relate challenging it is to set this up and how long it takes and how much of lines of code you actually need to do this in a declarative way. And with just this one line of code, new VPC, everything is for you, ready to set up, ready for you and set up with the default values. And for you actually to deploy resources into this VPC. Then we also have level 3 constructs, which are like composition of multiple resources across different services. This is the example that you actually have seen before, where we're going to create an application load balancer with the corresponding security groups, task definitions, the listeners, but it also creates the Fargate servers together with the IAM rules and policies needed for the service. And for the logging, it creates the log groups and the task definitions just by providing the 2 parameters. That's the ECS cluster and the name of the Docker image from the public Docker Hub repository. And this actually shows how powerful level 3 constructs can be and how you can create your own abstractions that you can share publicly or privately within your organization. So now let's take a look on how we can deploy our own Go application using CDK. And using CDK with Go. So what we're going to do is deploy in something like a URL shortener, which has been written in Go and will be deployed as a Lambda function. We're going to expose this Lambda function to the outside world using an API gateway for which the user can interact with. And a URL shortener also needs the storage to translate between the shortened URL to the original. And for that, we're going to use a DynamoDB table. So let's take a look. Okay, let's now deploy our Go application using CDK on AWS. First things first, we need to install the CDK CLI, and we can do that by using npm. So what we do is npm install -g the AWS CDK. And this will install the CLI, and from there you can use the CDK command to init your application. So what we're going to do is say CDK init, add language is Go. You can also provide other languages, but as this is in Go talk, we're actually going to use Go in this way. So let's execute it. And the CDK CLI will actually create a bunch of files for us. And from now, actually, all files are there, and we can now do something called like CDK synth, which actually will synthesize the code that has been created to generate CloudFormation. And we can actually look at this output by using this synth command. So if you're familiar with AWS CloudFormation, you will actually see, become quite familiar. And the demo resource that it actually creates is an SNS topic. But we're going to change that for our application, of course. So let's look at the files that has been created. So as you can see, it creates a Go mod file and CDK JSON. It initializes a Git repository for you with a README. And I think the file that we're mostly interested in is in the go cdk.go file. And over here, this is actually the infrastructure as code that we're going to use. So let's look at the file and what's in it. So as you can see, there's a bunch of imports. There's a structure created for the stack properties. There's a function to new up a new stack. And as you can see over here, there's already the topic that has been created by the initialize command. There's a main entry point, and basically what's in that main entry point is the creation of a new app, the creation of the stack, which will be assigned to the app, and then the app.synth, which actually generate the Lambda function. There's also some ways for you to use in different environments by specifying the environment over here. But this is not something that we're going to do now. So let's go back to the code that we're going to put in to deploy our application. So let's remove this. If we look at our architecture, the first thing that we want to create is a DynamoDB table. So to save you some time of looking at me typing, I've copied in some of the code that's needed to create a DynamoDB table. So we create a variable called table, and we say AWS DynamoDB.new table, and we provide a stack. That's the stack that we're going to use. Then we provide a name. In this example, the name is table. And as you can see, the string is in GSAI string. The reason for this is because we also want to manipulate the strings from other resources. So you can see an example later on. And for this, we actually have to provide string type pointers. And this is how we're going to do that. And the last argument that we provide is the table properties. And one of the things that we need to have in the table properties is the partition key. The partition key contains of a name of the type slug, and it has this type attribute string. You can also provide other attribute types, so like binary and number. And as you can see, because I'm using Go in this editor, I have all the IntelliSense that I needed to discover how to create those AWS resources here. So now we have created our table. We want to create our Lambda function. So for our Lambda function, we are using a construct, the Go function, which is in the package AWS Lambda Go. So as you can see over here, we say new Go function. We also provide the stack and the name, which will be function, and the properties, the Go func properties. What we provide over here is the entry, which is actually our Go application. It's called Go URL. So what we're going to do is actually copy this application into our project. So copy Go URL. And if we look at the application, it's just a plain Go application that you already know on how to create. There's a main package. We created some commands, and the API is using Max. So actually with two calls that you can do. One is to create a URL which returns slug to us, and the other one is actually accessing the URL, and that will return a redirect permanently to where the slug is done. And for the storage, we're using DynamoDB. So what we're going to do is actually deploy this application over here by using a Lambda function. We point to the application by specifying it in the entry. Of course, our application needs to know which DynamoDB table it should actually write the URLs to. For this, we're using environment variables, and we can do it like this. So we provide a map of the type string with the point string. The name will be DynamoDB table, and we reference the table which we created before, and we reference the table name to that, meaning that the table name will be generated over here by this construct, and the name of the table that will be generated will be actually provided to the environment variable. This way you actually make things in code, and if things are changing, it automatically change with it in the Lambda function later on. Okay, now our Lambda function needs to be able to access the table, to read and write table entries to that. On AWS, we use something called Identity and Access Management, where we provide a role towards a Lambda function, which has the permissions to do that. And normally in best practice is to use least privileged. Normally you have to create this role, you have assigned the privileges to that role, and you have to assign that role to the function. With CDK, there are actually some convenient methods for you to help. So what you can do is say table, and then grant read write data. And then we can actually put in the resource that we want to grant these permissions to, which is the handler. So this will actually take care of all those things, like creating the IAM role, assigning the policies with the permissions to actually read and write data to the table. So now we want the API gateway be created that actually proxies the requests coming through the API gateway to our Go application. So what we're going to create is something called an integration. And that integration will be a new Lambda proxy integration. We provided some properties. One is the handler, so which points to the function handler, and that we just created previously. The other one is that we have to provide the version 1 of the payload format provided by the API gateway. API gateway v2 has a new payload format. Only the Lambda Go library still is on version 1. So that's why we say that the payload format should be version 1. And then once we have created this integration, we actually provide this integration to an HTTP API, which is in the AWS API gateway v2. And again, here we provide a stack, we provided a name called API, and we give it to the properties to say that the default integration will be the Lambda integration that we provided before. So we now have all the resources created. If you create an API gateway, the URL that you're going to invoke is actually generated by the API gateway. And we want to make use of that URL. So what we're going to do is actually output that URL back once we're creating the stack. So how you can do that is you can do like AWS CDK. We say new CFN, which stands for CloudFormation output. Again, we provide the stack, we provided a name, which will be the API URL. And we say that the output props value will be the API URL. So this is basically all the code that we have to write. Now let's deploy this to our AWS and let's see if we can get it running. Okay, in order to deploy using CDK, what we type here is CDK deploy. And what it will do, it will execute our code, it will synthesize it towards CloudFormation, and it will actually start deploying our code to our AWS account. So it starts building the assets. And over here, it's going to ask, because our code contains some changes to the security scheme. So it comes to create IAM roles and change policies. So it actually will ask you if you want to deploy these changes, just an extra level of security. In this case, it's okay. So we say yes. And you can now see the CDA stack starts deploying. And it will start with creating the CloudFormation change set and push it towards the CloudFormation API. Now let's wait for the CloudFormation stack to be deployed. It creates the table, it creates the IAM roles. Okay, now the stack has been deployed and it returned to me the API URL. So let's start using this URL, see if our application now works. So using this curl command, we say curl sh. We provide an application JSON content type. Let's put in the URL that just has been shown to us. So as you can see, it returns to me the slug that has been generated and also what was the original URL. So now we can actually use this slug by going to the then we paste in the slug. And as I do so, you see now it returns and moves permanently towards that URL. Meaning that our API that we have deployed, our Go application, is working. So now you have seen how easy it could be to deploy your Go application using CDK with Go. From the IDE you already know, and just the number of lines you needed to deploy this type of application. AWS also provides something called the AWS solution constructs, which are like architecture patterns for you available as open source extensions for CDK. It helps you to assemble production-ready workloads according to the best practices that we provide for such solutions. So this is a growing library of best practices, and you can filter to find the right solutions for which matches your use case. So I recommend you to take a look and see if they can actually work for your solutions as well. CDK is an open ecosystem. So we have a public roadmap to show what features are prioritized by customer feedback. And we are happy to have many contributions from the community and would like to love to have your voice in this future development of the tool. There are also many other resources that you can be found around CDK, like the awesome CDK repository, which is like a collection of third-party level 3 construct libraries. There's also something called CDK patterns, and feel free to inspect how others are building service compositions. So there are plenty of resources out there if you want to get started with CDK, such as the CDK workshop, which is a workshop that guides you step by step in how you can use CDK to deploy your applications. There are also CDK examples to show you some example implementations using CDK, and many more. Feel free to drop into our GitHub channel or look us up at the GitHub repository, where you can create issues, but also pull requests and interact with the team if you need certain features added to the framework. There's also community resources out there, like the CDK patterns. Also, something that's nice to mention is CDK 80s, which is CDK to generate Kubernetes manifest files. So you can also share them among your organization and have the same benefits that you see also for AWS resources, but then tailored to Kubernetes. For this, I would like to thank you listening to my talk. Hopefully, CDK is a tool that's something for you to look into, and enjoy the rest of your conference. Thank you.